You know that feeling when you're on a bike ride and everything is just perfect? The pavement's smooth, the path is clear, and you feel like you're just gliding along. And then there are the other rides, the ones where it's all bumpy and stressful and you're gripping your handlebars just a little too tight. What if I told you we could actually measure that feeling? Well, today we're going to dive into the science behind what makes a perfect ride. So that's the big question, right? We're going to unpack a really fascinating study that did something amazing. It translated all those feelings a cyclist has, comfort, safety, stress, into cold, hard data. The kind of data a city planner can't ignore. So to figure out how we can measure that perfect ride, we first have to understand a problem every single cyclist knows. I'm talking about the huge gap between a feeling and a fact. I mean, we've all been there. That difference between a good ride and a bad one, you feel it in your bones, right? But how do you explain that feeling to the person who decides which roads get repaved? You can complain, sure, but that's just an opinion. What if we could turn that opinion into solid evidence? That's exactly what researchers set out to do. See, for cities to build better, safer bike lanes, they need more than just stories about bad rides. They need objective data. So the scientists realized to put a number on how safe or comfortable a ride feels, they first had to measure what a cyclist is actually doing on the bike. And to do that, they couldn't just use a stopwatch and a clipboard. No, they needed a special kind of tool. They needed a high-tech detective that could pick up on clues even the rider might miss. And here it is, the star of our show, the Instrumented Probe Bicycle, or IPB for short. Now, it might look like a regular old commuter bike, but don't let that fool you. This thing is kitted out with some serious technology, basically turning it into a rolling, data-gathering science lab. And we're not just talking about strapping a GoPro to the handlebars. Oh no, we're talking about a whole suite of super sensitive instruments designed to capture every tiny vibration, every little steering correction, all this stuff a rider experiences but might not even be consciously aware of. So let's peek under the hood here. The inertial measurement unit, the IMU, that's really the heart of the whole system. It feels every single bump and vibration. Then you've got a steering sensor that tracks how hard the rider is working just to stay upright and balanced. And of course, you've got wheel sensors and GPS to pinpoint exactly where and how fast all this is happening. It gives you a complete second-by-second picture of the entire ride. All right, so they've built this amazing high-tech detective. Now what? Well, it was time to hit the streets and do some real on-the-road science. No, they didn't just pick some perfectly smooth, pristine bike path. Nope. They designed this test loop on real-world roads. It had everything a cyclist deals with: hills, intersections, even a roundabout. And, most importantly, it had sections with really different levels of pavement quality. But this high-tech detective couldn't solve the case all by itself. It needed witnesses. So the researchers recruited 60 volunteer cyclists to take the IPB out for a spin. Now, this is a really crucial detail. These volunteers weren't all pros. They got a whole range of skill levels, from total beginners to really seasoned riders. And, as we're about to see, that diversity turned out to be one of the most important clues in this whole investigation. So, the rides are done. The scientists have terabytes of data from 60 different cyclists. Now comes the fun part: decoding the ride and figuring out what it all means. And the very first thing that jumped out of the data was a massive difference in how people rode the bike, and it all came down to their self-reported skill level. The sensors showed it plain as day. Less experienced riders tended to have this slight side-to-side wobble, a little zigzag as they went. Their steering was a bit more frequent, a bit less efficient. On the other hand, the experienced riders, they were super smooth. They held a much straighter line and made tiny, precise corrections. But what about the road itself? How do you grade a road? Well, for that, the researchers used a standard system called PACER. It's pretty simple. It's a 1 to 10 scale that road engineers use to rate the quality of the pavement. A 10 is a brand new, perfect road, and a 1 is, well, a total disaster. And this right here is where it all comes together. Check out this data from the bike's accelerometer. That's the sensor that measures vibrations. See that section labeled C? That part of the course had a really low PACER score, just a 3, meaning it was in pretty bad shape. And look at the data, a massive spike in high-frequency vibrations. It's a direct, measurable link between the road quality and what the bike felt. This is the magic right here. This is the whole point. It's not just a feeling anymore. It's not just a cyclist saying, ouch, that section is really bumpy. It's a graph. It's a number. It's a quantifiable, undeniable physical event. It turns a subjective complaint into an objective engineering problem that actually needs a solution. Okay, this is all seriously cool science, but what does it actually mean for your daily commute? How does all this research lead to building better bike lanes for all of us? It basically creates this clear, data-driven path for making things better. It starts with that rider's feeling, this road feels awful. Then, that feeling gets backed up by the IPB's objective measurements, and that gives city planners the hard evidence they need to justify repairs, to target the absolute worst sections of road, and ultimately to make cycling safer and more comfortable for everybody. So by analyzing all this data, the researchers were able to cook up a kind of a recipe for the perfect ride. And no surprise, smooth pavement is a huge plus. But they also put numbers to the negative impacts of things like steep hills, which add physical strain, and vehicle traffic, which adds a whole layer of psychological stress that really influences how people decide to get from point A to point B. So, what are the big takeaways here? First, that gut feeling you have on a bike, it's not just in your head. It is a real physical thing that we can actually measure with science. Second, a road that feels totally fine to an expert might be absolutely terrifying for a beginner, and our bike lanes need to be safe for everyone. And finally, data like this gives cities the power to make smarter, evidence-based decisions to build the kind of bike-friendly towns we all want to live in. It really gets you thinking, doesn't it? We all have that one street, that one stretch of bike lane riddled with potholes that we just dread. So if you could send a high-tech detective like the IPB out into your neighborhood, where would you send it first? Definitely something to think about on your next ride.